Here are the answers for the section 13-4 day 2 homework assignment, where we have some word problems. On page 508, problem number 1. The man who has invested in a stock found that in 1 year through dividends, his income increased by 5%. If his income were to continue to increase at that rate for 5 more years, and his original income was $2,000, what would his income be at the end of this time? So I took that information and I translated it into the symbols we're using for sequences. So when it says his original income was $2,000, I thought of it as being the first number in a sequence. So that's the value of A. When the problem said his income increases by 5%, I thought about what number you would times by for R that would represent increasing 5%. And that's 1.05. Then I need to think about what term of the sequence I'm interested in to answer the question. So it says that he starts with $2,000. So the $2,000 is his initial money, and it's the first term in the sequence. The problem says that after 1 year, that has increased by 5%. So the second term in the sequence is 1.05 times 2,000. And what that represents is the money after 1 year. Now the problem says, what would his money be after 5 more years? So this number here would be after 1 more year. This number would be after 2 more years, after 3 more years, after 4 more years, and after 5 more years. It's this number in the sequence that gives us his income in that year. Well, which number is that? That's 1, 2, 3, 4, 5, 6, 7. That is the 7th number in the sequence. So I know I wrote A sub 6, but that's a mistake. It's actually the 7th number that I'm interested in for the answer. So let's use the general formula for a geometric sequence. A sub n equals A times R to the n minus 1. And we want to find A sub 7. So fill in 2,000 for A, 1.05 for R, and 7 for N. And then evaluate this on a calculator. That's $2,680. Next, number 5. A town planning commission finds that because of a new missile plant, the population has been increasing by 10% annually. The population is now 15,000 people. What will the population be expected at the end of 4 years? So the population now is the first term in our sequence. That's the letter A. If there's a 10% increase, the value you could use for R that would represent that is 1.10. If you times by 1.10, that creates a larger number that shows a 10% increase over the previous one. Now, which term in the sequence answers the question? This number right here that's created by multiplying 15,000 by 1.10 is the population after 1 year. The next number would be the population after 2 years. The next number is the population after 3 years. And the next number is the population after 4 years, which is what we're asked. So which term is this? 1, 2, 3, 4, 5. It's the 5th term. So I can see once again when I was kind of writing the homework out to get it ready that I have not put the correct value. It's the 5th term we want to find, not the 4th term. So let's use our general formula. A sub 5 equals 15,000 times 1.10 to the 5 minus 1 power. And that is 21,961 people. Problem 5 in the book says to give the answer to the nearest 100. So this would round up to 22,000 people. So after doing 2 homework problems, I can see that I have a tendency when I first look at the problem to not correctly identify which term in a sequence is answering the question. So that points out that when you solve these, you need to put extra thought into which term along the sequence actually fits what the question is asking. Next, number 6. The value of a car depreciates 20% the first year and 5% each year after that. What is the value of a 4-year-old car which originally was $3,000? So I'm thinking of the value of the car as a sequence of numbers. So initially, it's worth $3,000. But after 1 year goes by, and the car is now 1 year old, it's no longer worth the original amount of money. We're told it's only 80% of 3,000. And we can take a calculator and actually find 0.80 times 3,000. After 1 year, the car is only worth $2,400. Now going back to the sentence in the book, it says each year after that, it depreciates 5%. So when we want to find this next term in our sequence, it has to show a 5% reduction in value. So the value in that year is going to be only 95% of the $2,400. And that term is after 2 years. The question asks us, what's the value of the car after 4 years? So we need 2 more terms in our sequence of numbers. And it's this one that we want to figure out. Now let's put careful thought into which term that is. First, remember that we didn't multiply by the same value each time. It wasn't until this step here where we're going to start timesing by 0.95 every time. This first number is kind of an aberration. Let's not look at this and instead think of the 2,400 as the first number in a sequence. In that case, the number that we're interested in is the 1, 2, 3, 4th number in the list. So once again, I'm off by 1 on what I first was thinking I needed to figure out. Let's use our formula. A sub 4 is equal to the starting value, 2,400, times 0.95 to the 4 minus 1 exponent. After 4 years, the car will only be worth $2,057. Next, number 7. A side of an equilateral triangle is 20 inches long. A second triangle is drawn inside by joining the midpoints, as shown in the picture in the book. So you're definitely going to want to look at that picture in your handout. The process is continued as shown in the diagram. Find the perimeter of the 5th inscribed equilateral triangle. Well, we need to know the starting value, so the largest triangle has a perimeter of 60. I got that by going 20 plus 20 plus 20. Then, the second triangle, what's its perimeter? Well, the sides of the second triangle look to be half as long as the sides of the original. So 10 plus 10 plus 10 is 30. Now the third triangle that's drawn inside there, the sides of that triangle are only half as long as the previous. So they're each 5 inches, and the perimeter is 15. I think that's enough to see the pattern. We can see that our value of A is 60, and that our rate is a half. We're timesing by 1/2 each time as we move to the right. We were asked for the 5th inscribed triangle. Do I have the right number identified? This is the original triangle. This is the first inscribed triangle, a triangle drawn inside of another triangle. This is the second inscribed triangle. Then we would have the 3rd one, 4th one, and 5th one. And it's that one that we want to figure out. Well, which number in the sequence is that? 1, 2, 3, 4, 5, 6. And man, oh man, I am doing a terrible job of getting the correct one identified when I just originally read the problem without actually starting to think out what the sequence is. We want to find A sub 6. So we can use our general formula. A sub 6 equals 60 times 1/2 to the 6 minus 1 exponent. And that answer is 1.875 inches. And the last word problem, number 8. A jar contains 500 cubic inches of air. So I wrote that as the first number in a sequence. On the first stroke of an air pump, it removes 20% of the air, leaving 80%. So the second number in my sequence is 80% of the 500. Or we could actually type that in and get what that is as a number. There are now 400 cubic inches of air in the jar. That term of the sequence was the first stroke of the air pump. Now the next number in the sequence would represent the second stroke of the air pump. And it's going to be 0.80 times the previous answer. The question says, how much air is left in the jar after the fifth stroke? So this number would be the third stroke of the pump, the fourth stroke of the pump, and the fifth stroke of the pump. Am I off by 1 again? 1, 2, 3, 4, 5, and 6. Sure enough, we want to find a sub 6. So a sub 6 is equal to 500 times 0.80 to the 6 minus 1. After the pump has worked for 5 strokes, there will be 163 cubic inches of air left in the jar. For the review, we're going back to page 507 written. Number 2, we're asked to write the first 4 terms of a sequence where the first number is -9 and the value of r is 2. So -9 is written first and then times by 2. -18, -36, -72. Number 8, we're asked to find t sub n, and we're told n is 5, so we're asked to find t sub 5. We're asked for the 5th term. This is a lot like the word problems we were doing where we were trying to find a certain term of a sequence. So our general formula is t sub n equals a times r to the n minus 1. T sub n can also be written as a sub n. We want to find t sub 5. So start with 12 and multiply by 1/3 to the 5 minus 1 exponent. And that makes 0.148. Number 16. Substitute these different values of n, starting with 1. So 1 minus 1 is 0, and -1 to the 0 power is 1. Now a 2. 2 minus 1 is 1, and -1 to the first power is -1. Now the 3. 3 minus 1 is 2, and -1 squared is 1. Do you see the pattern? I think it goes -1, then 1. Now we're asked to graph this. 1, 2, 3, 4, 5 on the n-axis. And it looks like we're going back and forth between +1 and -1 on the f of n axis. So here's 1, 1, 2, -1, 3, 1, 4, -1, and 5, 1. We get this oscillating pattern of dots. Now page 503 written. Find the sum. So start by substituting 1 for j. 4 times 1 is 4. And then 2 for j, that's 8. And then 3. And then put in 4 for j, which is 16. And so on, all the way up until you get the 10th one. Now you can write out the full expansion and then add it up. Or we could try to do this quicker by using the formula. This is an arithmetic sequence where the first term a is 4 and the value of d is also 4. So let's use our formula for summing an arithmetic sequence. To sum 10 terms, you go 10 divided by 2 times 2 times the first term plus, and then 10 minus 1 times d. This makes 5 times 8 plus 36. And then take a calculator and type that in. The result is 220. Number 10. Find the sum of this arithmetic progression. Like the last question, we're given A and we're given D, and we're given a certain number of terms to add. So let's use the same formula. 16 divided by 2, 2 times 1/5, 16 minus 1, and now times D. This makes 8 times, and then take a calculator and figure out the stuff inside the bracket. That makes 6.4. So finally, 8 times 6.4. And the result is 51.2 if you use decimals. If you want to use fractions, that's 51 1/5. Number 16. Write the first 3 terms of an arithmetic progression. We know the first term is 2/3. But we want to get the second one and the third one. What we have to work with is the value of A, the value of L, which means the last term, and we're told what the sum of n terms is, 48. So let's use a formula involving the sum when you know A and L. It is n divided by 2 times A plus L. For S sub n, we can substitute 48. For A, we can substitute 2/3, and for L, 7 1/3. And then solve this for n. So you can times both sides by 2. We have 96 equals n times, and then 2/3 plus 7 makes 8. So divide by 8 to get n alone. And that answer is 12. Now that we know the answer for n is 12, it will help us to figure out what D is. So let's use the general term formula for an arithmetic. A sub n is equal to A plus n minus 1 times D. Now that we know n is 12, we know that the letter L representing the last term was the 12th term. So the letter L is A sub 12. So let's use 7 1/3 in place of A sub n, realizing that that means we're putting a 12 for n. This will allow us to figure out what D is. So subtract 2/3 from both sides, we get 6 2/3 is equal to 11D. Now divide by 11 on both sides. And the result is 20/33. Once you know D and you know the first number in the sequence, you can find the second number and then the third number. So 2/3 plus 20/33 makes 14/11. And 14/11 plus 20/33 makes 62/33. Here are the first 3 numbers in the sequence. Then number 26. Write this series with 4 terms using the sigma notation. Choose some variable as your index. It's common to use I or N or K or some letter like that. I'm going to choose N and count from 1 to 4 because there are 4 terms. Now we need the general formula to write next to the sigma symbol. What kind of series is this? The value of A is 1, and from term to term, it looks like D is -2. So let's create the general term formula for an arithmetic using this formula. So A sub n equals 1 plus n minus 1 times -2. And then simplify the right side. So 1 minus 2n plus 2, and this makes 3 minus 2n. That formula goes right on the side of the sigma symbol, 3 minus 2n. Here is the answer in sigma notation.